If you compare the specifications between UDM Pro and EFG about the hardware, you can see for UDM Pro, it has 4-core ARM CPU at this frequency, and for EFG, it has 18-core ARM CPU at higher frequency. Just on paper, you may draw a conclusion immediately. The EFG has much higher throughput than UDM Pro, right? Yes, in general, that's a correct assumption, but depending on whether we are talking about one connection or multiple connections. Before go to the details, let me show you my lab testing results. In these two lab environments, I have different UniFi gateways, UDM Pro and EFG, but I use the exact same switch so that we can exclude the factor about switch when it comes to the throughput of the Inter-VLAN routing. Then I will use two Mac Minis. They both have 10 gigabit connection to the switch, and there's difference for the connections between UniFi gateway and the switch. For UDM Pro, I use a 10 gigabit connection, but for EFG, I use a link aggregation. So in total, I have 50 gigabit uplink. For both cases, I achieve the maximum uplink I can get. Then for both gateways, of course, there might be a lot of settings which may impact the speed, but I already make sure. For example, for firewall, I keep everything default. For ACL, I have nothing. For SSL inspection, I don't have it enabled. And for both gateways, I have the exact same VLAN configurations. So I have the default network and VLAN 66 and VLAN 88. They are both managed by the gateway itself. Okay, let me start with EFG. So in lower part of the screen, I have two Mac Minis. They are both connected to the switch, and now they both belong to the default network. In the left side Mac Mini, let me start iPerf3 server. Then in the right side, run it in client mode. I run it in bi-direction, so I will see the throughput for both transmitting and receiving. By default, it will only use one thread, which means it will only use one connection to the server. Okay, let me run it. You can see the speed is very good. I cannot get it better. Okay, perfect. And now let me change their VLAN settings so that they will belong to different VLANs. Now the left side server belongs to VLAN 66, the right side client VLAN 88. Let me run iPerf3 in client mode. I'm only using one connection. Okay, you can see the speed is very disappointing. Just a little bit more than 2 gigabit, right? 2.3 maximally. So it's much lower than previously when the two Mac Minis are in the same VLAN. To increase the total throughput, of course, I can increase the parallel threads. For example, I say 10 parallel connections. Okay, you can see the aggregated throughput is about 8 or 9 gigabit per second. Much higher, but still lower than 10 gigabit. And this is aggregated throughput for 10 connections. So now you see the effect for EFG. Let me do the exact same testing, but use UDM Pro. Now the two Mac Minis are connected to the UDM Pro environment in default network. In the left side, start iPerf3 server. Then in the right side, start the client using one direction by default. Okay, so for one connection, it can achieve close to 10 gigabit speed. Good enough. Now let me move the two Mac Minis to the two different VLANs. Now they belong to different VLANs. From the client side, start the testing. First, just one connection. Okay, see, it can achieve close to 4 gigabit speed, even though it's still lower than 10 gigabit, much higher than EFG. That's a surprise. Then if I force 10 parallel connections, see, it doesn't improve a lot. So this is kind of understandable because we all know the UDM Pro is much weaker than EFG when it comes to hardware, right? A big surprise is for the one connection testing, the UDM Pro has much higher throughput than EFG. That's a trigger for me to make this video. I will dig deeper to go to the backend of the two gateways to understand why. But before that, let's first exclude the client as a factor. So in both clients, let me show the CPU utilization. Now let me run the one connection scenario one more time. This time run it for longer time. Okay, you can see for both the IPv3 server and the client, they use multiple CPU cores concurrently, so we can exclude the client as a factor in the slow one connection performance result. You can see for both sides, the CPU utilization is not high at all, and they are using multiple cores at the same time. So we are good about the client. Now let's go to the backend. Let me SSH into the two gateways. Then just to understand the different behavior for EFG when it comes to multiple connections or single connection, let me go back to the two Mac minis, and then from the client side, let me start one connection testing again. This time make it run longer time. Okay, then go back to SSH. So in the SSH session for EFG, let me run top command, use a little bit higher refresh rate. See, both the top processes begin with ksoft IRQD, but with different suffix, 5, 7. So in fact, 5 or 7 is the index for the CPU cores. If you remember for EFG, it has 18 CPU cores. So totally, there are 18 ksoft IRQD processes running, each one for each core. And now there are 2 in the top list because we are running one connection but bi-direction. That's why there are 2 processes handle the 2 directions. And you can see each process already use up 100% of the CPU. That's why for each direction, the speed cannot be higher. The CPU is the bottleneck. And then if I go back to the Mac Mini, this time let me only run for one direction. Let's say run for download. Okay, run it. Then go back to SSH. You can see now there's only one ksoft IRQD process because we are running the testing only using one direction. Now it's crystal clear. One process handles one direction. It's just based on our observation. The ksoft IRQD is only associated with one CPU core, right? Let's confirm that's really the case. In Linux, there's a thing called CPU affinity. It's also known as processor affinity. It is a property of a process that binds the process to a given set of CPUs in the system. To check the ksoft IRQD's CPU affinity, we need to first know their process IDs. So let me run ps command and only list those ksoft IRQD processes. You can see there are 18 of them. Let me pick some random one. So this column is for process ID, right? Let me pick some example, run the command task set, use the process ID from above output. Then let's see for the first process, current affinity mask 1. Then let's try the second one, 2. Okay, for a given IP flow means it's a 5-element tuple, source IP, destination IP, source part, destination part, and the protocol. So for each such IP flow, the gateway will use one ksoft IRQD process to handle it. And because each such process is only associated with one CPU core, that IP flow's throughput is limited by the CPU. How powerful the CPU core determines the throughput for one such connection's speed. Let me go to UDM Pro to show you in backend how the interrupt is handled. So you know when the network traffic goes via the LAN part of the UDM Pro, why the gateway even knows the traffic is coming? Because of the hardware interrupt, right? Then the software need to react, need to handle the interrupt. To show that information, I need to first know what's the PCI part for the LAN part. So let me use Linux command ls PCI. I can see this particular one is for the SFP plus 10 gigabit Ethernet adapter, which is for the LAN part. It's 00000002. Note down the number. Then let me go to the two Mac machines. Let me start a one direction only testing for downloading. Okay, it's running. Then go back to SSH. If I show the content of this information, process interrupts. Yeah, it's a long list. It shows each CPU core, what's the statistics for the interrupts it handles. And the very last column shows the information which we are interested in. You can see it's for Ethernet, either RX or TX, right? The very last part is the PCI part. Remember, we already found for the LAN part, it's this particular one, right? So let me restrict the display. So let me filter the result using the PCI part for the LAN part. Okay, this is what I want. See, I can see for this particular LAN part, for each CPU core, how many interrupts were handled, right? But this is just the static display. What I really want to see is the real-time information. How I can do that? Let me wrap this command by using watch. So I say for every half second, refresh the display. Yep. This is what I want. See the real-time change? Now the first CPU core is changing very fast. Of course, from time to time, other CPU cores are also changing. It's simply because there are some other traffics going on, right? But only this one is changing rapidly, which means this CPU core is handling the IPv3 testing. And just to double check, it's really the case, let me run top command. See, the Ksoft LQ0 is handling it. 0 match what we just saw from the interrupts. Okay, so we tried different ways just to confirm what we observed. We can conclude our understanding is correct. Now we understand why the bottleneck. Why for one connection, both EFG and the UDM Pro, they have much worse throughput. We are good about that part. But there's still a question unanswered. Why the UDM Pro has much better throughput than EFG for the one connection Inter-VLAN traffic? Let's find it out. According to the specifications for UDM Pro, for each CPU core, it has lower frequency than EFG. Then why UDM Pro has better performance, right? In the SSH sessions, let me run command ls CPU. This is for EFG. This is for UDM Pro. So you can see for EFG, yes, it tells us it has 18 CPU cores. Max frequency is 2 GHz. But for UDM Pro, it doesn't tell us the frequency information. However, we already saw it on the specifications, right? So it's 1.7 GHz. And there's another interesting related information in the output, which is this one, Boger MIPS. MIPS means million instructions per second. Useful information to tell the performance. But why Boger? So Boger means Bogers here. It's just a value that the Linux kernel calculates at boot time to calculate internal delay loops. It's not a real performance benchmark. That's why it has the prefix Boger. But we can somehow just to use this number to briefly tell the CPU performance, right? From the Boger MIPS, it seems the EFG has better performance than UDM Pro, right? So it still doesn't answer the question why UDM Pro behaves better in the single core performance. So I decided to install an external tool. It's called sysbench. It's used in Linux to do some benchmark on command line level. So I already installed it in both gateways. From the EFG, let me write sysbench, and I want to measure CPU. I want to specify 18 threads because EFG has 18 CPU cores, right? Let me write. You can see it simply measure the CPU performance by calculating prime numbers. So you can see the total time is 10 seconds. It gives you the total number of events. Then for UDM Pro, let me run the same command, but only specify 4 threads because UDM Pro has only 4 CPU cores. You can see this is the total number of events. It's lower than left side EFG. As expected, the CPU is less powerful for UDM Pro, right? That confirms the total bandwidth difference, the aggregated difference. Of course, UDM Pro is less performant. But let me run the same sysbench benchmarking again, only specify one thread. So in both gateways, let me run it. So in this way, I only use one CPU core. This result explains why UDM Pro behaves better in case of one connection. So see here, it has more events than the left side EFG. So that means the one single core performance for UDM Pro is better than EFG. That's a surprise to me, but that does explain what we observe. Okay. I believe now we have answers to explain the different behaviors when we test throughput for EFG and UDM Pro. This ends the video. Thanks for watching.